It's mid-April, just outside of Huntsville, Alabama. High school and college students from across the country have gathered at this farm to complete a project started 8 months earlier and could affect the rest of their lives. Their journey to the stars starts here. The NASA Student Launch Projects began as a way to encourage students to study science, technology, engineering, and math by taking them out of the classroom and literally into the field. These young scientists design, build, and test reusable rockets carrying a scientific payload they create. The goal? Climb 1 mile above ground level and drift safely back to Earth.
And there's the chute deployed. Beautiful chute in a beautiful sky.
There are 2 divisions of the NASA Student Launch Projects, college and high school. For the high school participants, work begins nearly a year before the NASA Student Launch Project launches with qualifying in national competitions. Those who do well are invited to submit proposals to participate in the coming year's NASA Student Launch Projects. College teams, on the other hand, don't have a qualifying competition. They submit a proposal to NASA detailing their rocket design and payload, just like professional scientists and engineers in the workforce. Once teams are accepted, their work begins in earnest.
Since August, we pretty much have met every single day, so really the excitement of being out here today when it's all boils down to one single launch. Our main came down nice, wasn't in the trees, thank God, so I guess our goal of closer to heaven actually did come true.
A lot of long nights after school, working and talking and yelling at each other.
The program fosters an interest in aerospace and encourages the use of science and math skills in a hands-on setting. But students also learn the challenges and requirements NASA professionals face. For example, students work closely with propulsion engineers at NASA's Marshall Space Flight Center in Huntsville. They meet via video teleconference to give detailed reports of their progress and receive valuable feedback from the same people who built the Saturn V, the Space Shuttle, and are designing America's next generation of space vehicles.
And we go through a conceptual design, a preliminary design, a critical design, which is also your final design. Then we go build it, and then you do your verification and your final flight readiness review. We do the same thing with the students. So we run them through the paces, and they see what the engineering design cycle is all about. I mean, we step them through step by step, tell them what to expect each step along the way and where they should be and everything. And it's really awesome. The students love it. They have to do reports, make up a full package for us, and it's really great practice for them to document their designs. Anybody can go build something in the garage, but to sit down ahead of time and plan out what you're going to do, and then do the drawings and think about everything, and then document it, for your design, and then once the design is complete, to document exactly what you have done is a really good exercise, and the students love it, the teachers love it, because it's a great opportunity for them to work on writing skills, technical writing, or just grammatical writing, and it's just an overall great project.
These scientists and engineers suggest ways to make the student rockets more efficient and safe, a valuable learning experience not lost on this group of future rocket engineers.
We've done a lot of risk mitigation charts, risk analysis, because safety is the primary concern. Anything that you're doing with NASA or with anything, especially in rocketry, is so critical that safety is first. And with the University Student Launch Initiative, what you do is you take all of those principles from your technical to your communication skills to working with teams, and you're able to put it all together, and it's just a beautiful synthesis that really simulates what it is to work in the real world.
The benefits extend to NASA as well.
For NASA, this is just an incredibly important event for these students. The opportunity to design and then build and then actually fly a rocket. I mean, how many students get a chance to do that? And just imagine what a leg up it's giving them on their engineering careers and their future prospects. These are the people from whom you're going to hire your next generation of workers and engineers, astronauts, and scientists. Each of these people have a passion. Each of these students have already said that this is what I want to do with my life. I want to build things, and I want to be associated with the space program. This is really what NASA is all about.
After nearly an entire school year working nights and weekends on the project, it culminates with a visit to the Marshall Space Flight Center for the rocket launch and final face-to-face meetings with the engineers who have mentored them for the past 6 months. Teams, teachers, and mentors go through a detailed safety briefing the first day they arrive in Huntsville, explaining the process students are required to follow on launch day. They also have a chance to share their designs and payloads with other schools and NASA employees at the Rocket Fair.
Where are you guys? We're sitting right over there. Oh, sure.
After an exciting day of comparing notes and general camaraderie, teams are encouraged to get a good night's rest in anticipation of a full day of rocket launches. The excitement builds as students arrive at Bragg Farm, just north of Huntsville, and begin assembling their rockets. Before they can even approach the launch pads, they have to visit the range safety officer with a checklist of improvements they made in just the last 24 hours.
Last night, we did hardware checks with all the teams where we took all their rockets completely apart. We identified a couple items and we wrote it down on a list. So they brought that list with their corrections up here and we checked it off. So we looked to make sure that they fixed what we asked them to fix, and they have. And so now they're just going back to put their rocket together and go fly.
Once the rocket passes a final safety check, the team takes their checklist to the launch control officer, who reviews the flight card, verifying the type of rocket and payload. NASA gets some help from some of the top amateur rocket enthusiasts in the country, who share the agency's vision of the student launch projects.
Get students to understand about aerospace technology, get hands-on experience with it, and experience launching their own rockets in a controlled and safe environment. The students are actually the future of aerospace for America.
Another group with eyes on this event is the Student Launch Project corporate sponsor ATK, the same company that tested and built the solid rocket booster for the space shuttle.
As the producer and manufacturer of solid rocket boosters, this makes sense for us to support rocket launches. And it's important because this is our future workforce. So these kids are wonderful and we love talking to them about their payloads, and there is nothing better than getting out here and launching rockets as they're getting inspired and learning about science and technology for our future workforce.
Why isn't this cool? I mean, we launched off high-powered rockets. We got to test blowing up black powder. You know, during class every day, you know, building the rockets, it was a real good hands-on experience. It was awesome.
Students learn quite a bit more than just the science of rocket propulsion. They learn about presentations, speaking to the media.
So it looked like a really good straight flight, and I'm happy with what we got.
And maybe most importantly, how to work as a team.
We all share love for rockets, and we all work hard together, and it's just fun.
After handing off the flight card, teams will talk to the pad manager, who assigns them a launch pad based on the height and design of the rocket. Finally, the pad is armed for flight, and after months of late nights, heated discussions, crash and burns, and presentations to real rocket scientists.
3, 2, 1, start!
Teams can earn awards in both the high school and college divisions, but ATK supplies a cash grand prize to the top college team. But for all the students, the rewards are plentiful. The lessons learned as a member of a team, the chance to design, build, and launch a working rocket, and working side by side with real rocket scientists.
It sounded interesting, and it's a good challenge, and it's fun, and you know, you get to make things fly and do cool stuff like come down here.
Coming out to such a great state and visiting NASA officials and launching rockets, it's such an awesome experience.
The NASA student launch projects bring the excitement of spaceflight within reach of these teenagers, while cementing the knowledge of science, technology, engineering, and math that could carry them to the stars. For more information on NASA student launch projects, including how to qualify, visit us on the web